In this practice, a 5 nanofarad capacitor is fully charged by a 10 volt power supply. Then it is connected in series with a coil, forming a LC circuit. The period of oscillation of the LC circuit is 5 times 10 to minus 5 seconds. Calculate the inductance of the coil and the maximum current in the circuit. So first, we connect the capacitors with the battery to charge. So this is C, positive charge and negative charge are stored by the batteries. Then it is connected in series with the coil. So after the enough charge are stored, positive charge, negative charge stored in the capacitors, then capacitor is connected with the coil, form the LC circuit. This is L and the capacitance C. Then when we study the LC circuit, omega frequency is given by 1 over square root LC. So if you consider omega t is a 2 pi, omega is the angular frequency times the period, it becomes a 2 pi. So t period is expressed 2 pi over omega. So this becomes a 2 pi square root LC. So at first we'd like to store the charge by connecting the batteries. V is a 10 volt. This is 10 volt. And the C is 5 nanofarad. We'd like to calculate the charge Q is calculated C capacitance times the voltage. This is 5 times 10 to minus 9 farad. 10 to minus 9 is a nano times 10 volt. So it becomes 5 times 10 to minus 8 coulomb. This is the amount of charge stored in the capacitors. Then we'd like to consider the LC circuit. The period of oscillations is this t is 5 times 10 to minus 5 seconds. So from this equation, we'd like to find this L. So using this equation, t equals 2 pi square root LC, you can express the L equal 1 over C times t over 2 pi squares. Then substitute. C is 5 nanofarad. 5 times 10 to minus 9 farad. And the period is 5 times 10 to minus 5 seconds over 2 pi squares. Then it becomes 1.266 times 10 to minus 2. So using the three significant figures, 1.27 times 10 to minus 2 unit is a Henry. So this is the answer to the first question, is a calculate the inductance of the coil. The maximum current of the circuit can be calculated. I is a derivative of the Q with respect to times. As a Q, we derive the Q equal Q cosine omega t plus phi. It becomes minus Q omega sine omega t plus phi. So maximum current given by the Q omega. This is a I max. So maximum current is equal to the Q omega. Omega can be calculated 2 pi over t times Q. So you can substitute all the numbers. 2 pi times 5 times 10 to minus 8 coulombs over 5 times 10 to minus 5 seconds. So it becomes 6.283 times 10 to minus 3 ampere. So express the answer with three significant figures. 6.28 times 10 to minus 3 ampere. Okay, this is the answer to this practice.